So hello, my name is Trisha G. I am the lead Java advocate for JetBrains, which means I do lots of advocacy around IntelliJ IDEA. I've actually worked for JetBrains for over 6 years now, but long before then, I was doing live demos with IntelliJ IDEA. I was pair programming with people and learned a lot about IntelliJ IDEA. And so my this talk is basically me, Trisha the fangirl, talking about how much I love IntelliJ versus Trisha G, lead Java advocate for JetBrains. So this is just my fangirl talk. That's to set the background. To set even more background, I have been a Java programmer for more than 20 years. I started at university where we didn't use IDEs. I'm not sure if there was an IDE back in those days, using Vi. And I've used a whole variety of IDEs throughout my whole career, including Visual Studio, because I did ASP back in the day. So the context of this is I've used a lot of tools for doing programming. I started using IntelliJ IDEA in 2006. And at the time I was like, oh, this is kind of nice. I kind of like it. But it's only when I started pairing with people in 2009 who really knew how to use the IDE that I started to really appreciate how powerful this tool is. And at that time, I was pair programming with people who are power users of Eclipse and of IntelliJ IDEA. They knew their tools very, very well. I just found that IntelliJ IDEA works better for my flow, for the way that I like to code, for the way that I like to work. So I tended to gravitate towards IntelliJ IDEA. I'm hoping to show during this presentation why that is, but IDE choice is a very sort of personal thing, and I'm not trying to say like anyone is better than another. I'm trying to say that when you know the tool and you find a tool that works for the way that you think, the way that you code, then that really helps you to become really productive. The contents of this presentation are based off a blog post I wrote, which is 20 things we love about IntelliJ IDEA for IntelliJ IDEA's 20th birthday. So if you go to this link, you'll be able to see all of those 20 things. I couldn't quite squeeze all 20 things into this presentation because we only have an hour. So I have broken it down into a number of sections. This blog post contains everything I'm going to cover in this talk and more. So do go and have a look later. The three main points I want to cover in why I love IntelliJ IDEA is the fact that it's an integrated development environment, the fact that it's intelligent, and that it helps me get into a state of flow when I'm coding. So let's first look at what I mean by an integrated development environment. Of course, your IDE should compile, run, and debug your code. In fact, in IntelliJ IDEA Conf, we heard in the keynote that the very first version of IntelliJ didn't actually come with a debugger. So maybe we don't even assume that they come with debuggers. But generally speaking, you're going to expect your IDE to compile, run, and debug your code. So I'm just going to take a quick look at this most basic set of functionality. Most people probably don't even know what the keyboard shortcut is for compile, because let's do Command-Shift F9. This will compile, where is it? Command-Shift F9. This will compile my code, but of course, IntelliJ IDEA kind of compiles things for you. You don't have to run the compiler. If I type something which is absolute nonsense, then it will tell you this is absolute nonsense. It doesn't work. Of course, I can, like I say, run the compiler and have the Java-C output to see what that looks like. But generally speaking, I don't need to do that in IntelliJ. It just kind of does it for me. So we can run our classes with Control-Shift-R, which will run it and output stuff into the run window at the bottom. And we can also debug with Control-Shift-D, which should stop on my breakpoint here. I really like the debugger in IntelliJ IDEA. It's really, really helpful. For example, if I step over with F8, I love the fact you get these comment style annotations of the values at particular areas. So I can sort of see in my code the runtime values of what's going on. Obviously, I can see my variables here. I can add a watch. There's not really much here. I get code completion here, which is quite helpful. And I can even, if I want to, I can even change these values as we go. So I can set the value to something else like new value. And then when I step over, I should see it outputs that new value instead of my original message. So the debugger is a really powerful tool to allow us to write code and to debug that code when it inevitably goes wrong. I'm not going to talk about it in a lot of detail because fortunately we had another presentation at IntelliJ IDEA Conf, which was some really useful deep dive tips on how to use the debugger in IntelliJ IDEA. And there was so much stuff in there I didn't even know. Do go and have a look at that talk. It was amazing. Right, so that's compile, run, and debug. So of course we expect our IDE to compile, run, and debug our code for us. One of the things that's really nice about the way IntelliJ IDEA works is the integration with build tools like Maven. So this particular project uses Maven. So I can see my POM file. I get with IntelliJ IDEA, for example, if I have a Maven project or a Gradle project, it will use Maven or Gradle to import that project. It knows how Maven and Gradle structure the projects. For example, that source main Java is production code and that test is my test code. So IntelliJ IDEA will use the fact that you are using a build tool, knows how that build tool works to configure your project for you. You don't have to manually configure anything. And it will also, of course, bring in all your dependencies. So here we can see, in fact, it says, I got these dependencies from Maven. So we can see those dependencies there. There's a slightly different view on dependencies, which is in the Maven tool window. Here we can see the dependencies, and we can see the dependencies of our dependencies. So we can see where various things get pulled into our project, whereas here they're just in a flat list. What else do we get from IntelliJ IDEA? We get code completion inside our POM file, including for things like version numbers. So I can actually just easily pick up a new version of, or in this case, an old version of JUnit Jupyter. And I want to show you one of my favorite tricks with the build tool integration here. So let's copy an XML dependency from Maven, and let's paste that into a Gradle build file. And it automatically turns it into a Gradle style dependency. That is like one of my favorite tricks of all time. It's so cool. So I can just easily copy stuff from one project to another. IntelliJ knows the context of where it came from and where it's going to and shapes it accordingly. So the stuff that I've been talking about for Maven applies equally for Gradle as well. So I can see in my Gradle tool window, I can see my dependencies, and in my project, again, I'll see that my dependencies came from Gradle. So everything, I should be able to configure everything via my build tool and have IntelliJ use all those settings to build and run my application. So I don't have to have one set of settings for my IDE and a different set of settings for continuous integration or production or whatever. It's all fully integrated. Version control systems. When I first started using Git several years ago, I found it a little bit tricky to get my head around. I'm not really a command line sort of person, and I found that the integration in IntelliJ IDEA made my life an awful lot easier. Let's take a quick look at some of that. We do have another talk from IntelliJ IDEA Conf about version control inside the IDE, so there's a bit more detail in that talk. This is just like a high-level view. So, for example, in my Git window, which I opened using Command 9, you can see the history, all the commits, who made the commits, all the branches. I find that quite helpful for getting, because I'm quite a visual person, getting an idea of like what's going on with the branches, what was merged when. If I want to do a branch or a rebase, I've got an idea of which thing I'm rebasing onto where. What else can we do? We can search these commits. So like I like to have a search for something like, let's have a search for any comment which has fixed in the name, for example. And I can do things like I can select it by user. A lot of these are me, obviously. I can view all my branches and including on the remote, and I can merge and rebase as well. Like I said, I don't really have any examples of that here. What else can we do with version control? So I can create a branch. I can create a branch anywhere. I could create a branch here, new branch, and I can check it out and automatically go to that branch or not. So I could just create it here in any arbitrary point, and I can do stuff with that branch. For example, I can really easily remove it here. So in the olden days, I used to have to use an external tool for doing my version control. Now I just use everything inside IntelliJ IDEA. Obviously, I can also I can commit my changes as well, and see my differences between what I did and see what the differences are here. That's not really a great example, but that is what it is. What's the other thing? One of my other favorite features, which I like to do inside IntelliJ IDEA is, let's go to this branch. Let me go back to all. I want to cherry pick something from this branch. For example, let's cherry pick this, and I can really easily just cherry pick that there. I can do a merge. Let's see, I think this is the thing I want. I don't want that. All changes have been merged, save everything. And then I can just commit that straight away if I want to. So we have a lot of the features we expect from inside IntelliJ IDEA. We expect from our version control system inside IntelliJ IDEA. So we don't have to leave our IDE at all. We get like a fully integrated experience. We can commit, we can merge, we can rebase, we can even do more complex operations like things like cherry picking or or managing our branches and so forth. I'm just going to revert that. So obviously we can also revert, roll back. Yes, remove my change list. Fine. Okay, what's next? Next is the terminal window. So if we decide that actually there's something that we can't really do inside the IDE, or we prefer to do from the terminal window, and one of the common things here is things like the some of the Git commands, we can do it from inside the terminal inside IntelliJ IDEA. So if this is something that we just prefer to do from the command line, we can still stay inside our IDE. We still stay inside our context of coding. We don't have to flick between different windows. We can use the terminal window inside IntelliJ IDEA. I do this a lot for things like command line running build files and things like that, and managing. I want to sometimes run my Maven file with a different version of Java, and I can easily do that from inside the terminal. So, for example, I could have multiple terminals, and I could have let's see what my Java home is here. Echo Java home. So here I could run it against Java 11, and here I could run it against Java 16. And then if we do something like, let's say we do Maven, you can't see, hold on. Let's see if I can move that up a bit so you can see better. If you do type a command that can be run inside the IDE, IntelliJ IDEA will say, actually, you can run it inside the IDE if you want to. You don't have to just run it from the terminal. Now, I might want to run it from the terminal, so I press Enter, which will just run it inside the terminal the way I expect it to. Oh, look, it failed. That's fascinating. What happened? Oh, yes, CD, Java samples. So we can run it. Did I say clear? Clean. Go away. For that. Maven clean. So that's fine. Or I could say, okay, fine. Take me to running it inside the IDE to see what it looks like inside the IDE. So I do Command and Enter, and it will run it inside the run window. And this can be quite helpful for finding if there are commands that we're used to using on the terminal, we don't know that it's supported inside the IDE, we can use this to find out how to do it inside the IDE. So it's quite a helpful way of providing a smooth integration. Database integration. Every single one of these, I'm going to want to say, this is my favorite thing because I love all of these features. In the past, when I was doing lots of enterprise development, I often needed an external tool to have a look at what was happening in the database. IntelliJ IDEA Ultimate has full database functionality inside the IDE, so I don't need a separate tool for that. Let's have a look. Let's go to databases. I've got, should we have a look at the settings? I'm connected to a MySQL instance, which is locally. Here it is. Here's the URL. And then I can see here this schema and the tables in the schema. I can even look at the values inside these tables. So I can easily sort of have a browse through. I can obviously see the shape of the table and what sorts of values are in there, which can be really helpful when I'm trying to figure out, like, how am I going to get this data, or how am I going to save stuff into the database? What's the shape of that? So it's all fully integrated inside my IDE. And one of the other things is, so then let's have a look at the other side of stuff. Let's say I have an entity, or let's say I have an entity. Oh, let's undo that because I want to show you. let's say I have an entity like actor, and it's not uncommon for us to have SQL strings embedded inside our Java code. And we can actually say, well, look, we can tell IntelliJ IDEA, this is a SQL string. This isn't just a Java plain old string. So I can do Alt-Enter. I can inject a language. I'm going to inject MySQL. Then I get code completion. So let's say, let's just get rid of that. So I can say select star from, and it gives me, if I'm connected to a database, it even gives me completion for like where I could be getting stuff from. So Sakila.actor, where let's say first name equals this, okay? Then I'm going to be like, well, actually, I want to test that out. So we can do Alt-Enter. Where was it? Thought it was an Alt-Enter. Command-Enter? Yes, Command-Enter. There we go. So Command-Enter to run it inside the console, and then it will say, look, give me the parameter, and let's say I want first name to find everything that where the first name is Chris. I execute that, and so I can test this particular query against our specific database, and it will show me what the results look like. So that's really helpful when I'm developing. I can just kind of play with stuff, try stuff out, make changes as and when I need to. And of course I can even do, can I jump to there? I'm going to jump to source. Yeah, so I can type freeform queries here. So select select star from wherever, and it will give me my code completion, so I can start playing with things, and then I can just run that. That'll give me my results down here. So that's a really helpful that's a really helpful integration from IntelliJ IDEA. We also, you kind of saw a hint of it here. We could inject MySQL as a language into that particular string there. We get support for all sorts of other languages. We can inject languages into our Java strings, for example, things like sometimes you'll have HTML fragments or JSON fragments, and you can treat those as real code inside your Java code. Obviously, IntelliJ IDEA also supports coding with JavaScript, HTML, Kotlin, and like a whole bunch of other languages. And so that's really helpful, especially if you're working on a polyglot or front-end and back-end application. And of course, if it doesn't support what you want out of the box, there's almost definitely a plugin which supports it. Let's take a quick look at plugins. So there's loads and loads and loads of plugins here, and you can just search for whatever you want. I generally have Presentation Assistant installed so that you can see my keyboard shortcuts at the bottom. And one of the other ones which I highly recommend is Key Promoter. So every time you use the mouse, it tells you you should be using this keyboard shortcut instead. So those are top plugins from me. Okay, so that was sort of the integration side of things, like why I think IntelliJ IDEA is a truly integrated development environment. I can do pretty much everything I want to do from inside the IDE. I don't have to context switch. I don't have to use another tool. I don't have to go somewhere else. Now I want to talk a bit about why it's an intelligent IDE. So inspections are those intelligent suggestions inside your code, things that you might want to do to shape your code differently. Sometimes they're shown as like underlines or warnings. So for example, if we look here, we have a suggestion, an inspection which says your if statement has an empty body. So obviously it's got an empty body. So IntelliJ IDEA will say, I'm not really sure you want to do this because it's not doing anything. And it will give you suggestions. For example, I can remove the statement. Or maybe if it might give you some other suggestions. So let's say we have else, let's say we say, then we do that. Then the if statement has an empty body. The suggestion, oops, I'll do it again. The suggestion then is not to remove it because now it has an else. I can't remove the if. The suggestion is to invert it. Then I can remove that statement. So it will give me suggestions for ways I can reshape the code. These are sometimes they're possible errors. Sometimes they're just suggestions of a better way to do stuff. Let me give you another example. Sometimes you see them as gray code. So here it says it's a redundant call. So let's see what IntelliJ IDEA suggests. I'm like, okay, what's a redundant call? Why is this redundant? So it suggests I can inline it. Cool. So that's just simplified my code for me. So inspections are, they often give you your little yellow markers here, and they will give you suggestions for ways to improve your code. Let's see if have we got any other inspections to have a look at? We have got, right, no. There are loads and loads and loads of inspections. So, but they are one of my favorite things about IntelliJ IDEA, because you write your code, you get your code to work, and then you use inspections to potentially improve your code or change it so that it's more readable. A similar feature is intentions. Let's open some intentions. Let's open something with intentions. Intentions here, you'll see there aren't any warnings in this class. So it's not the same as inspections where it says, hey, look, I think you might have done something which could be better. Instead, if you've got a piece of code and you think maybe I want to do something different with that, you can press Alt and Enter, and it gives you a bunch of intention actions. So here I could invert the if condition, extract something, remove the braces, or I'm going to try replacing the and with an or to see if it changes the readability of the statement. So I can do that and go, okay, that's kind of interesting. That feels a little bit better. But what if I then also invert the if condition? Then I lose the not and it switches these two things around. Then I'm like, actually, I think I prefer that. So we can use intentions to try out different ways of expressing the same thing to see which one is more readable, more understandable to us. There are a lot of intentions around loops. For example, this is using the enhanced for from Java 1.5. I could replace this, and all things inside IntelliJ IDEA are searchable. So I could start typing here to find an indexed for loop, and so then it will replace it with a for loop with an index for loop. But then IntelliJ IDEA says, then we get an inspection warning, which says, hey, look, you can actually just replace this with the enhanced for because you're not doing anything with that index. But if we were doing something with the index, like I'm going to use live templates here, we were going to print it out, then I don't get that warning anymore because I'm doing something with that index and it can't be replaced easily with the enhanced for because I need that index. What else is there? Oh, and reverse direction. So one of the other things I like about this is you can also, for example, reverse direction of for loop, and it will count, instead of counting up to some unknown value or some known value, I guess, I'll count down towards 0. Sometimes this might be more readable. Sometimes counting down towards 0 can be more performant because the computer might be able to optimize that for you. So sometimes you want to do that. But the point is to allow IntelliJ IDEA to suggest different ways of doing stuff, and for you, the human programmer, to make a decision about whether that's more readable, more understandable, more in line with your team's coding standards, and kind of go forward from there. New language features. This comes mostly under inspections, but one of the things I really love about IntelliJ IDEA is, especially now, my job is to stay on top of what's new in Java, all the new language features which are coming in, what can make life a lot easier for us as developers. This is practically a full-time job. For most developers, we don't want to be learning every single new feature in Java all the time. What's more helpful to us is if IntelliJ IDEA can say to us, hey, look, there's this new language feature which might help you in this particular case. And this is exactly how I learned how to use Java 8. So let's have a look at the Java 8 inspections, which most of you should be familiar with. So when Java 8 came along with lambdas and streams, I've been programming in Java for 15 years, hadn't used another language for a long time, and didn't really understand what lambda expressions were all about. So when I first started using Java 8, I would write out my functions in this long-winded anonymous inner class way, so I could kind of get my head around what it was doing. And then IntelliJ says to you, look, hey, you know what? This can be a lambda expression. So then you replace it with a lambda expression and you're like, all right, oh, that's quite cool. I think I understand a bit more about how lambda expressions work. Similarly, you've got some intentions here which say things like I can remove the redundant parameter types. And so I can kind of play with the shape of the code to see if it's more or less readable. The next thing is, all right, so I can simplify this lambda expression here. And down here, I can use a method reference. And when I first started using Java 8, I did not get method references. I did not understand them, and it didn't come naturally for me to choose a method reference first. I could kind of get the hang of using a lambda expression, but what I would do is I was write it as a lambda expression, and then get IntelliJ IDEA to change it to a method reference. And if it looked more readable, then I'd keep it as the method reference. So here, the method reference sort of makes sense to me, because what I'm trying to do is I'm sorting this array, comparing the values by ignoring the case. So this feels a bit more readable in this particular case. Again, this is where IntelliJ, it makes suggestions to you, and you as the human developer, you get to decide, does it make sense to me, or is this not really readable for me, not really understandable? Is it adding complexity or removing complexity? So this is Java 8. Most people are probably already familiar with this because most developers are on 8 or higher. There are, of course, this continues throughout all the different versions of Java. For example, let's have a look for switch expressions. In Java, I don't know, 14, we got switch expressions. So I can replace this switch statement, this old-fashioned looking switch statement with labels, with a switch expression. And this gives me one of the lovely new switch expressions with a lambda style syntax, which is a lot shorter. I also get the option to, I don't need to assign it to a variable and then return that value. I can actually just inline that too. So IntelliJ IDEA will suggest further improvements. This next squiggly is because I've got duplicate code, because I use this example somewhere else in this code base. And we'll talk about duplicate code later. So I quite like these things because we have, IntelliJ has helped me to shrink down this long-winded switch statement to a shorter switch expression. I can decide that actually that's more readable for me, and I'm going to keep that. That's fine. Similarly, we can also use it for LBTI, for using var, which came in Java 10. This is not, var is one of those entirely optional things. So IntelliJ won't warn you that you should use var, but you can use var when you're declaring things if you want to. So that again gives you total control of, does this seem more readable with var or not? So if I have a long line like this, which seems a bit like, this does seem a bit heavy on the old boilerplate, I can use IntelliJ IDEA to replace the type with var. I can add a static import for this because this method is readable on its own, and similarly use a static import for that. And I've just made this a bit shorter, and then I have to decide whether I think that's more readable or not. Okay, so that's how IntelliJ IDEA helps us use new language features. I did say we were going to come on to detect duplicates. IntelliJ IDEA is obviously it's looking at your code, trying to figure out what your code does. So it has in its head, if you like, a model of your code. And one of the things it can do with that is find duplicates in your code. So let's look for duplicates. When duplicates are in a single file, particularly a small file like this, you can spot them yourself. So here's what IntelliJ is saying. It's saying duplicate code fragment. Yes, I can see that because this is pretty much the same as this. This is much more powerful, of course, when these duplicate code fragments might be scattered across your code base. So it's in an entirely different class that you haven't looked at for ages, and you don't know that that's actually duplicated. Let's take a look at some of this, though, because the interesting thing about duplicate code detection is, if you see here, this variable name is not the same as this variable name, and these don't look exactly the same. So it's not as naive as a simple search through your code base for exactly the same code. It looks for something which is a very similar shape, and then suggests that you could do something. So here it actually suggests, right, you can actually just extract a method from this duplicate code. So let's do that. Let's see what that looks like. I think we're going to call it, what does it do? We're going to call it build string, because that seems to be doing that. And then we have now the main method and the duplicate calls the same build string method. And then we just have that one method. We don't have duplicate code throughout our code, throughout our class. So that's quite helpful. Another thing, which is a variation on the same theme. Let's go to extract method. If we see here, this main method has a loop and this print list has a loop as well. Now, if I extract this into a method, which is one of the nice refactorings that we have, let's call it print steps. Probably already got one called print steps. Print steps. Then IntelliJ IDEA says, look, you can actually, this bit of code is really similar to that bit of code, so you can actually just replace that. And so then it will do that for us. I'm going to show you another top tip, which is not actually supposed to be in this presentation. At this point, I don't really like the fact that the print steps is called here and print steps is called here, and my private method is in the middle. So what I'm going to do is I'm going to rearrange code. Oh, it's not going to work. What have I done? Rearrange code. Yes. And then it will move my private method to the bottom of my class, because I've set in my settings that I want all my private methods at the bottom of the class. That's one of my favorite things. Fun bingo tip. Try and spot the number of times I say the word favorite in this presentation. So detect duplicates. IntelliJ IDEA is really clever at doing that. Let's move on to refactoring. I've already shown extract method. There's loads of refactoring inside IntelliJ IDEA, and if you saw the keynote for IntelliJ IDEA Conf, they do talk about how refactoring was one of the first features that kind of went into the IDE, things like rename, rename method, rename class, rename package even. So refactoring was kind of a core thing that IntelliJ IDEA did right from the very beginning 20 years ago. And it's still one of the most powerful, most useful things that the IDE can offer us. For example, I'm just going to give you a small example. You probably know loads of the refactoring stuff anyway. Extract variable. What's it called? Variable? Or is it called something else? It's called introduce variable. Introduce variable. Cool. So let's say we have a method like this. We call orders.size a whole bunch of times, and we think, well, actually, why don't we just reduce this duplication? We're going to extract the variable here. I'm going to use Command Option V or Control Alt V on Windows. And IntelliJ IDEA says, okay, you could replace just this one with a variable. You could replace the 2 that are inside this if block. You could replace the 4 that are inside this if block here. Let's put that back down there. Or you could replace all 7 that are in the method. So let's say we do, let's say we just do that one. We call it size. And it just applies it to the scope that we said, and that's kind of cool and that's useful. And then you think, oh, actually, no, I didn't really want to do that. I think I want to do all of them. Then you can do inline to put that back where it came from. And then let's say we want to do that. Hold on. Again, replace all 7 occurrences and do that. So you just use the refactoring to see what the code looks like if you move stuff around. Refactoring will always move the code around in a completely safe way so that it functionally does exactly the same thing it did before. So you can you write the code, you make it work, you show that your tests pass, and then you refactor it, you reshape it to something which is more readable or makes more sense or is more broken down, more reusable. The refactoring allows you to come back to that code and reshape it in a way, whichever way you want. What else have we got for refactoring? So yes, let's introduce variable. That's probably the simplest one. We have extract parameter. And again, this is an example of where IntelliJ IDEA does intelligent refactoring. So let's say I want to, here I'm using string value only to get the length from the string. So actually, if length is the only thing we need, maybe we should just pass in the length as a parameter. So I'm going to do Option Command and P to extract parameter. And then IntelliJ says, look, if you put this in as a parameter, you don't need the string value anymore. Do you want me to delete it? Or I will delete that actually. And so you say, okay, and it's going to change the call site to use the new parameter. So instead, it just passes in the string.length. So extract parameter will do more than just introduce a new parameter to the method. It will also say, look, hey, you don't need these other ones anymore, and make your method a more sensible shape. Oh, one more refactoring I wanted to show you. So those are kind of what I call everyday refactoring, sort of relatively simple ones that can be done as you go. There are bigger structural changes. For example, we have, what's it called? It's called replace inheritance. Sometimes people, sometimes you'll find code which uses inheritance to provide like reuse and reuse basically. And often inheritance is not the best way to reuse code. So one way to get the same functionality is to use, is to delegate particular things to that superclass instead of inheriting from it. So IntelliJ gives you the option of, where's it gone? Refactor this, which is Control T, replace inheritance with delegation. So yes, I'll just accept the defaults. It removes the extends and gives me a private field superclass and then does delegation. So there's more than one of these types of what I call bigger structural refactorings. But again, IntelliJ IDEA will make these changes, change it across your code base so that it's still doing the same thing. It's just it's got a different shape. So it can be quite a good way of doing bigger refactorings, breaking stuff up, moving stuff into superclasses or pushing stuff down, that kind of thing can help us migrate our code into towards a shape which is better for us. Okay, so that's refactoring. Data flow analysis. Data flow analysis, there was a whole presentation on data flow analysis by Tagir, so I don't want to go into it in lots of detail. He knows this inside out and he's got loads of detailed stuff in that presentation. I just want to give a really quick demo of an example of data flow analysis. So we've got data flow analysis here. You'll sometimes see IntelliJ IDEA says things like, this is always false, or this can't be this value, or this logic branch cannot be reached, because IntelliJ IDEA is kind of able to reason through your code with the sorts of data values that could go through it and tell you this doesn't make any logical sense. That's what computers are good at. With humans, when we look at something like this with all these ifs, you kind of have to load into your brain, okay, like if the value is no more than 10 and less than 25, I'm going to get this, but if it's less than 50, and you're kind of loading these different values into your brain, but that's exactly what a computer is good for. So IntelliJ IDEA says, look, the value cannot possibly be 3 at this point in time. And you're like, okay, I don't really understand why that is. Tell me. And in find cause, it says left bookend, which is the value, is in 50 to 75. Why is that? Because if it was less than 50, the method escaped here. And if it's more than 75, the method escaped here. So it must be between 50 and 75. So then you can say, okay, fine. Then what do you want me to do? Well, you can just remove that. You don't need it anymore. So that can really help you to simplify your code by removing code that's just not needed. When you're running code, particularly Java code, which is optimized, sometimes from a performance point of view, that doesn't necessarily make any difference because it could get optimized away if it's never used. But from a human programmer point of view, we can't optimize away that code so we don't see it if it's not used. The best way to do that is literally remove it if it's not used, and IntelliJ can help us to do that. And another thing which is useful here is, let's see, Control-Shift-P, press that twice here. Why do I always get this wrong? Control-Shift-P twice. What am I doing wrong? Yes, that one. And then I press it again, and it will tell me not only the type information, but the values that it can be at this point in time, which is really helpful because then I can make reasoned decisions about what can I do from here. Like, do I care about some case here where, you know, if it's 60, it needs to do something else, then I can reason about that. Okay. And the final thing I wanted to say on the intelligent side of IntelliJ IDEA is that so context is queen because I'm a woman, not a man, so context is not king for me. The IntelliJ IDEA is aware of the context of your code. It's aware of the shape of your code, things like the way it's going to run, the way your dependencies come in, the data that flows through it. So it will give you relevant suggestions at the right point in the code. It doesn't overwhelm you with, it's a very powerful IDE, but it doesn't overwhelm you with it like a million different things that you could do each individual line of code. It just says, look, at this point in time, this might be helpful, or over here, this might be helpful. So the contextual information is super helpful for us as programmers. We only have to think about that one piece or those 2 or 3 things at that point in time. We don't have to think about everything. And that frees us up to just concentrate a bit more on what it is we're trying to achieve. Which leads me to my final section on promoting flow. I've been trying to write a presentation demonstrating how IntelliJ IDEA promotes the state of flow since forever, since well before I joined JetBrains. But it's a really difficult thing to demonstrate because flow is something, a state of flow is something you reach after like maybe 20 minutes. It's not something you can kind of demo by standing up on stage and then like coding away. It's also, it's something that kind of comes naturally when you're trying to solve a specific problem. And when you're doing a video or a demo or something, this is something that's been rehearsed. So anything that I show you which shows the state of flow is going to be a bit over rehearsed and a little bit artificial. But what I want to do is kind of give you a vibe of the types of features that help me, the types of features from IntelliJ IDEA that help me to code the way I code, like constantly moving forward, trying to solve a particular problem, not thinking about the how, but thinking about the what. What am I doing and why am I doing it? What am I trying to achieve? So we're going to do live coding, live demo for this. And we're going to create, this is a toy project I've had for a little while. I'm trying to create a Sudoku puzzle generator and solver. So I'm using that for the purposes of this demo. What we're going to be doing is we're going to do some of the basics of generating a Sudoku puzzle. I don't really want to go into the business domain of what is a Sudoku puzzle. The simplest thing is it's one of these squares. It's got rows, it's got columns. Each row has the numbers 1 to 9 with no duplicates. Similarly, each column has the row 1 to 9 with no duplicates. And so it leads itself to an interesting programming problem because it's entirely like a logical mathematical problem which is easily solvable by computers and by tests. So we're going to test drive this because I'm a big fan of test-driven development. So let's go straight to our generator test. The test we want to write is when you generate a Sudoku grid, apparently I read it somewhere that it needs to have at least 17 items in or it will not be solvable. I don't know where that comes from, but that's a business requirement, so we're going to code that. I'm going to use live templates to create my first test case. This is a live template that I've created specifically for JUnit 5 tests. And this test is going to be, should have at least 17 items. Cool. All right. Now, what do we need for this? We're going to need a new generator. I want to assign this to a variable. There's a bunch of different ways to do that. I can do Alt-Enter to introduce a local variable. Or if I undo that, I could do .var for postfix completion, which is one of my favorite things. Or what I often do, because my fingers remember how to do this, is just literally introduce variable at that point in time. That's not very flow, is it? I just showed you 3 different ways, not getting on with it. I don't want to talk too much about the IntelliJ IDEA features, so keep an eye on the bottom for what the keyboard shortcuts are. But I might end up saying what they are anyway. So now I've got a new generator. What do I want to check? I want to check. Can use a match assert. Oh, you know what I could do? Will it do this? Assert that. Assert that. Okay, never mind. Match assert dot assert that. I want to assert that the generator, I'm going to get a puzzle from the generator. Oops. Okay, I don't have one of those. What do I need to do? Because I haven't created that in my generator class. So what I'll do, the way that I like to code is I'm going to write my test to say what I want it to do. And I'm going to think about, I want it to go red. I want it to fail first to begin with anyway. So I'm just going to do the bare minimum to get the test to compile and run. So, oops, I get IntelliJ IDEA to create this method for me. It's going to return me a grid. I happen to know that because that's what Sudoku grid looks like. I'm going to use smart completion here. You'll see that what I did is as soon as I said new, IntelliJ IDEA went, okay, well, the only thing that fits there is grid. So I'm just going to smart complete that away. So I go, okay, fine, I'll do that. Navigate back to the test. So now I've got a puzzle, get number of filled squares. I want the number of filled squares to be 17 or more, greater than or equal to. So let's see, greater than. If I press smart completion twice, then it will, the first time you'll see it goes, first time I press smart completion, it says, I don't really know what that is. But then when I press it again, it goes to look further afield to see if there's anything that vaguely looks like that method. And we see there's something called matches greater than or equal to. So I'm going to say greater than or equal to 17. Fine. I'm just going to static import that because that's a little bit long. Same here, static import that. Okay, so this is my test. I want to make sure that my generated puzzle has at least 17 items. So let's run that. Oh, let's run it a bunch of times for reasons which we will look at later. Let me just get rid of that for now and do it again. Let's run that again. Okay, so it should have at least 17 items. But it was 0. Why was it 0? Well, I haven't put anything inside the puzzle yet. So let's go back to our generator. Let's start adding things into our grid. To add things to our grid, I'm going to use refactoring to put this into a field. I want to initialize it in the constructor. Now, again, I don't have to type all of that stuff. I just say to IntelliJ, look, now I need that in a field. Make that happen. So I put that into a field. And then what else do I need to do? I need to put some values in it. So I'm going to use grid dot set cell value. So let's set, what I'm going to do is I'm going to use, what does this take? This takes a row index, a column index, and a value. And the reason why those are typed, well, this is neither here nor there. The reason those are typed is because otherwise that's 3 integers and it's really confusing. Now, again, I can use smart completion to just fill in all the stuff I need. So I want a row index of, let's just add it at index 1, and a column index of index 1, and a value of value 1. Right. Now let's rerun the test, which is, I've got it as Control F5. It fails again, but this time it says, look, you've got 0 values in your grid. And I'm like, that's a bit weird because I should have 1 value in my grid. Okay, so why don't we go back to our test? And why don't we take a look at this suspect get number of filled squares method? So I can navigate to this using Option, Command, and N. Nope, no, it's not B, I meant. Get number of filled squares returns 0. Okay, well, that can't be right because if I'm inside the grid, this is in my grid, I expect it to return however many values are in that. So I have a test which is going to test this because I didn't want to have to write the test in front of you while I was doing the live demo. This is going to say, this is a JUnit parameterized test where I put in a number of different values and test the same thing with different values. So what I'm going to do is this comes into number of values, set up the grid with a specific number of values, and then test that it has those values in. So let's run it. This only works for 0 because it returns a hard-coded 0 value. So yes, that's not very surprising. So why don't we go in and why don't we fix this test? Fix this method, I mean. What have we got? We are a grid. We have a number of rows. We have a number of columns. All right. So I think what I want to do is I want to iterate over. This is where I'm thinking as a programmer. What do I want to do? Not necessarily how do I want to do it. Not what syntax do I want, but what do I want to do? So what I want to do, I want to iterate over all of the rows and then iterate over all the values in those rows. And then if there are values, count them up. So what do I want to do? Iterate. So let's type iter, which is a live template, press tab, and then it automatically suggests, okay, you can iterate over the rows or the columns, or there's some other things I can iterate over. Fine, let's iterate over rows. Now what? I want to iterate over all the values in there. So let's type it again. It goes, okay, for each row in your rows, there's going to be a cell in that row. Okay, fine, just accept that. I didn't have to type any of that. I'm just like, I know I need to iterate over this and then iterate over the values inside there. My last thing is I want to check to see if the cell has a value. If the cell has a value, then I want to add up the number of, I want to increment the number of values in this grid. Just add 1 to the count. So if there is a value, so I'm going to use if, I'm going to use complete current statement to finish up all the bracket syntax for my if. And then I'm going to use smart completion. No, I'm not going to use smart completion. Can I do it twice? Oh, yes, I can. Use smart completion twice to find anything which could be a Boolean. What could I be checking for? If the cell is empty, actually, I want to do the opposite. If the cell is not empty, I'm going to use postfix completion again. Then what do I want to do? Then I want to increment the count. Fine. And then you just get IntelliJ IDEA to make all your code compile for you. Create local variable count. Fine. And then I will want to return the count. And again, make IntelliJ, make the code compile. What's wrong? I want to bring int count into scope. Fine. And then there's still one more error. Count has not been initialized. Again, get IntelliJ IDEA to initialize it. So you're not thinking about what is the syntax of Java. You're thinking about iterate, increment, return the value, and then just get IntelliJ to do everything else for you. Okay, let's see if we can rerun the test. What happens? Yes, everything passes. Okay, so given that this method, get number of filled squares, is now returning the correct value, what do we want to do? We want to go back to our original test and see if we can get that to fail in the correct way. So I'm actually going to use control to run anything. I want to rerun my generated test method. So let's rerun that. Fine, now it's failing for the right reason. I've only got one value instead of 17 values. Let's go to generator and let's, can I wrap this in an if? No, what I wanted to do is I want to use live templates for I. Create an iteration loop. I'm going to iterate. It needs to have at least 17 items. So why don't we say, well, I is less than 18, do something. Add these values to the grid 17 times. Okay, but I don't want to add the value 1. Don't want to add every single value at row 1, column 1, because then it's just always going to be overwriting the same value. So why don't we just put it in a random place? So we'll have a new random, fine. And then we're going to say random, oops, actually that had a good idea there. I could say random next int between 0 and 9, doesn't include 9, so it goes 0 to 8. I'm going to copy that, because copy-paste coding is absolutely acceptable. Copy that. I'm going to move this down here. This has got a bit long. And then I want to do the same thing with the value, except that I actually need to add 1 to this, because I don't want it to be 0 to 8. I want it to be 1 to 9. Now, so I'm trying to add 17 items into my grid with a random row index, a random column index, and a random value. Let's see what happens when we run this. Ooh, we get a duplicate value exception. The value 6 is already present. Now, Sudokus don't allow duplicate values in the same column or the same row. So what I'm going to do is I'm going to brute force this. I'm going to add a surround with try catch. We're going to catch a duplicate value exception. And we're going to ignore it because we're just brute forcing our way through this. Just keep running it until we get the right number of values. So ignore this. Brute force. Rerun. Now this seems kind of weird. Why is it failing? Because we've only got 14 items, but we said do this 18 times. All right, that's odd. Why don't we run this again and see what happens? In fact, why don't we run it multiple times? So I'm going to take this and I'm going to run it, repeat 10 times. Apply that, okay that, and rerun that. Oh, hold on. Where's my run? What am I looking for? Configurations. Oh no, what have I done? I need to run the configurations that I've just. There we go. Now it's doing it. So I ran it 10 times. It ran it 10 times for me. It passed a couple of times because it inserted 17 items, and it failed a few times for different reasons. So that was 13, that was 15, that was 13, that was 16. Now, why is it randomly failing? Because we're using a random number. So actually, what we want to do, our statement here is incorrect. We don't want to try this 18 times. We want to run this until there are at least 17 items in our grid. So we can get IntelliJ IDEA to replace this with a while instead. And instead of being while I is less than 18, what we want is we want grid get number of filled squares is less than 18. And then IntelliJ IDEA says, although you've got I and you're incrementing it here, but look, F2, nope, F2. You don't need this. You're not doing anything with it. So we'll Alt Enter and remove it. And it just removes all the noise that we don't need. Now let's try rerunning it. And it passes. Yeah, we have code that works. Right, and then the final step for me in the red-green refactor, I'm not trying to teach TDD, honest. I'm trying to show how like IntelliJ would just help you incrementally figure out what you want to do, figure out how to achieve it. Then when it's working, which you can prove with a test, then you can make changes. So for example, this code looks a little bit clunky. So why don't we static import that? Why don't we static import that? And why don't we, this is a bit weird, so why don't we extract that into a method? Oops, well, let's use extend selection to do that. Let's extract the method. I'm going to call this random row index, no, random index, because it will also work for column replace. I don't want to replace that. I'm going to use this as, I'm going to call this random value. Okay, so then hopefully everything still passes. Ta-da, it all works. Right, what have we done? We've used IntelliJ to create a test. Let's go to the test. We created a simple test, optimize imports, created a simple test which checks that our code meets a business requirement. Then we created the code that meets that business requirement. All the time that was happening, did you notice that the code was compiling all the time? IntelliJ IDEA helps us to stay in that mindset of always green. It's always compiling. You're always, you don't have to like break it and then fix it everywhere. You do the simplest that will keep it compiling, then just incrementally add to that code and move it around and just change it a little bit as you go along. So let's take a very quick, in summary, let's take a very quick look at some of the features that we saw in that particular demo. We were talking about, oh, did I press the right one? No. I used the keyboard almost everywhere. I used the mouse a little bit to show what was going on, but keyboard shortcuts are the fastest way to work. I was always a mouse person to begin with, but I trained myself to use the keyboard shortcuts in IntelliJ IDEA. And once your muscle memory has all of that, you're not thinking about, where is this thing? How do I do this? Your fingers just do it for you while you carry on thinking about what it is you're trying to achieve. So keyboard everywhere is really important. IntelliJ offers at least 3 different ways to do everything. You don't have to use the keyboard, but it is much faster if you can learn the keyboard shortcuts. Code completion. Code completion, particularly smart completion, IntelliJ IDEA will offer really intelligent suggestions as to what it is that will go in here. You're looking for a Boolean value here. These are the only methods that return Boolean values. Is this one of the things that you're looking for? Postfix completion allows you to be always typing forward. You don't have to be like, right, I'm going to create a new thing. Oh, now I need to go back to the beginning and declare the type and the name. No, you just type VAR on the end and it will do that for you. So postfix completion is designed to help you keep typing forwards all the time and not move the caret around all over the place. Complete current statement, Command Shift and Enter. As soon as you've kind of filled out more or less the basics of what you're trying to do, press complete current statement. In a normal statement, it will always put the semicolon on the end, but it will also do things like if you're in the middle of an if statement, give you your parentheses, give you your curly brackets. It will basically put in all the shape of the statement that you don't have to type, particularly braces and semicolons. Code generation. We saw a couple of forms of code generation. One, I was using live templates for a few things. 2, I quite often use code generation for things like, we used it for creating a new method that didn't exist, the get puzzle method. So you can code from the outside in. You can say from your test, look, I think I kind of want something that looks like this, and get IntelliJ IDEA to generate that. Obviously, you get basic types of code generation too, like creating getters, setters, toString, hashcode equals. But code generation is more interesting when you're just trying to stay in the flow, like type the way you want something to look and just get IntelliJ to generate it so that it compiles. Refactor as you go. Extract variables if you think that that's going to be more readable. Use a static import if you want to shrink the amount of code on the line. Extract a method if that's going to make it more readable, like for example in the random case. So refactoring is not like a big fat effort that happens afterwards. As you're writing your code, you're extracting a variable, you're extracting a method, you're doing the small refactorings that just help keep the code more readable and understandable to you as the developer. Inspections and intentions can help you a lot. What did we see in the inspections? Can't remember a specific inspection, but we used intentions when we switched the for loop to a while loop. So we kind of used IntelliJ to point us in a direction of, okay, this isn't working for us. What else could we try that kind of fits this shape? And I was particularly using test-driven development. So I find IntelliJ IDEA really helpful for this TDD loop of write the test, get the test to compile, run the test, then fix the test. And when the test is fixed, then refactor. So it just keeps you in the flow, keeps everything green all the time. Create the APIs, you used it. So I already mentioned this, how you code, particularly from a test, also from if you're in one service trying to call another service, you code against the API you want as the user of that API and get IntelliJ IDEA to generate it. Run anything. Run anything is one of my new favorite features. It's control, and it means that even if you're not in that class, that test class or the application class, you can run whatever you want by pressing control, and then typing the name of the method or class that you want to run. Stop everything. Oh, I didn't show stop everything. Command F2. If you've got multiple services running, you can use Command and F2 to just stop everything. And search everywhere. Oh, I've not mentioned search everywhere. So search everywhere is really, really helpful for finding things like your Maven window. Where's my Maven window? View tool Windows Maven. Or you can even look for, you can tab across here and use it to, oh, I'm not in the right place for that, am I? Well, you can use it to search for git commits and things like that. It's really helpful. You can search everything, literally everything with search everywhere. One of the things I use it for is I use it to do tab placement. So if I want to put the tabs at the top, for example, I can do that with search everywhere. So I use it quite a lot for doing settings. Right, so finally, the end of the talk. Everything I've covered is covered in this blog post, 20 things we love about IntelliJ IDEA, and there's loads and loads and loads of other things there. So if you're kind of if you want to look at one specific feature, if you want to find links to the help documentation for something, if you want to find different demos of some of the things I've been talking about, it's all here at this particular blog post. Oh, press the wrong button again. Yes, and that's the end. And yes, this would be the opportunity for comments. Please feel free to ask me any questions over Twitter or over, we have a mail alias for the Java advocates at JetBrains, which I think is javaadvocates@jetbrains.com. Feel free to ask me anything over an asynchronous channel like that. Thanks very much.